Well, hello guys and welcome back to Mr. G Physics. Here's Mr. G and this time we're going to be solving questions about momentum and impulse that I took from this consolidation material. I hope it helped. But before we start, if you didn't subscribe, don't forget to subscribe to the channel and I'll see you in a minute. Well, as I said, we're going to be solving questions from the consolidation material. I developed this consolidation material with help of Prof. Rodriguez and it's a quite good consolidation, which a lot of questions have two different tests, as you can see here. We're going to be solving question 2 today, which is related to momentum and impulse. The whole material is about momentum and impulse, and this question states the following. A bullet of mass 20 grams is fired from a stationary rifle of mass 3 kilograms. Assume that the bullet moves horizontally. Immediately after firing the rifle, recoil or move back, calculate with a velocity of 1,2 meters per 1,4 meters per second, calculate the speed with which the bullet leaves the rifle. So let's solve that question. But before we solve the question, let's write the data. This is important data. And for us, we're going to take forward as positive. This is entirely up to you. You can write forward a positive, backward positive. It's up to you. And let's see the data. We have that the mass of the bullet is 20 grams and the mass of the rifle is 30 kilograms. So let's take bullet as 1, mal of the bullet is 1, this is equal to 20 grams, and mass 2 is the rifle, that one is 3 kilograms. So you cannot work in grams, you are going to convert, and I recommend you to do it in the data. You have 20 divided by 1000, and that is equal to 0,02 kilograms. That is the mass. Let's go to the velocities that we have in the data. First of all, note that they were at rest. Initially, they stationary. So the velocity 1 and 2 are the same, equal and 0. So velocity initial 1 is equal to velocity initial 2, and that is, let me write the vector notation, is equal to 0. Now, the velocity final 1, that is the velocity of the bullet, that is what we are looking for. Guys, if you think you are going to get confused with 1 and 2, you can write 1 is a um, bullet, and 2 is the rifle. It's entirely up to you. Okay, that's it. Now, the recoil speed of the rifle, which is 2, final velocity 2, is equal to negative because it's backward, and I say forward is positive. So it's negative 1,4. 1,4 meters per second. Guys, what are we going to use here? We have to use the law of conservation of momentum. Let's start from the point I told you in a previous view you may start. M1V initial 1 plus M2 V initial 2 is equal to M1 V final 1 plus M2 B final 2. That is or could be the starting point. You don't have to start from the anything before that. So the rest is substitution. It's quite simple. Momentum is really an easy topic to get marks now. So if you substitute, which we are going to do, M1 is 0,02, so it's 0,02 multiplied the initial velocity, 0 for both of them. Let's write it like this. Let's substitute it anyway. 3 multiplied by 0, and this is equal to 0,02 multiplied by the final velocity 1, which is what I'm looking for. Be careful, don't you get confused of what you are actually looking for, plus the mass 2 is 3, and the recoil is negative 1,2 meters per second. I'm not going to write the unit. I was going to substitute the unit, and thus it the data, the substitution is 1,4. Guys, it's 1,4, no 1,2. I thought it was wrong here. 1,4, here is 1,4. There we go. Let me get my coffees, the one that keep me making me that mistake. And guys, the rest is substitution. So we have that everything here is going to be 0 and 0, and then the rest is just calculation here. The final velocity is equal to, and I'm going to calculate quickly, we get that this 210, let me redo it, is is 210 positive, 210 meters per second. They're asking you to calculate the speed. The speed is a scalar quantity, so no direction needed. It means that the final answer is that one. The final answer is 210. Let me make that one look like a 10 meters per second. Guys, this is the final answer. There are going to be 4 marks for this one if you well, you can give ticks. There's one for starting with the formula there, one for here, one for there, and one for the final answer. Quite simple. The next question says the bullet strike a stationary 5 kilogram wooden block fixed on a flat horizontal table. So there is a wooden block, and that bullet, after leaving the rifle with a velocity of 200, and let's write it here, this speed is equal to 210 meters per second because we did calculate it just now, 210. All right, they say strikes that specific wooden block of 5 kilograms. The bullet is brought to rest after traveling a distance of 0.4 meters into the block. So that bullet go into the block a distance of 0.4 meters there. Refer to the diagram below. Calculate the magnitude of the average force exerted by the block on the bullet. So you have to use Newton's second law in terms of momentum. All right, so let's see how can we do that one then. This one is question 2.2. 2.2. Now we're looking for the magnitude of the average force. So we're looking for net force there, net average force, if you will. That is question mark. So we are going to apply Newton's second law in terms of momentum. All right, so what is that going to be? F net is equal to, let me write it maybe like the way that you get it in the exam, multiplied by the time is equal to change in momentum. All right, so if you go furthermore, you say that F net multiplied by the time is equal to mass final velocity minus initial velocity, and that is how to calculate it. But guys, we having a problem. We don't know the time. The time is not given to us, so it was not so simple as it looks. So we need to calculate the time. Now, how are we going to calculate the time? Well, we have to use equation of motion. We have to use equation of motion, and we have to see, according to the data, which one can we used. There are many. I'm not going to now look and show you all of them. But if you say that the displacement is equal to initial velocity plus final velocity divided by 2 multiplied by the time, that could be a formula to help you because you have everything. They're telling you that the distance is going to be 0.4 meters. The distance of the bullet, or the distance, the displacement that bullet is going to move inside the block, is equal to 0.4 meters. Okay, and we need that one there. So we come in here, we have the formula, and we can actually substitute because we do have everything in here. This one is 0, I say, and let me call it, don't want to make same mistake, 0.4. So it's 0.4 equal to initial velocity, that is the velocity of the bullet before striking that wooden block, which was 210. So it's 210 plus the final velocity of the bullet is 0 because it's going to stop in the block, divided by 2, everything multiplied by the time, which is what I'm going to calculate here. So quite simple calculation. You first say 210 divided by 2 is 105, and then it's 0.4 divided by 105. The answer is 0.0038. So the time I get here is equal to 0.0038 seconds. All right, so that is the time. And then we can substitute already in the Newton's second law in terms of momentum, which is what we are going to do right now. I'm going to substitute here on the right side. I don't want to go to a new page. I don't think it's anything. So F net which is what we are looking for, multiplied by 0,0038 is equal to, you know what, it's not going to fit in here. I'm going to have to press it too much. There's not a need for us to press that much. A new page, and then let's go there. So F net multiplied by the time, which is 0,0038 is equal to the mass of the bullet, because the question asks for the force that the block exerts on the bullet. So it's the mass of the bullet, the one we're using here. So it is 0, where am I here? 0,02 multiplied by the final velocity 0, and the initial velocity is positive because we say forward is positive, 210 meters per second. So if you come here and you solve this one, you get that F net is equal to, and guys, this is just calculation, 0,02 times 210 divided by 0,0038, and I make a mistake here. 0,02 times 210 equal to divided by 0,038. You get that the answer is negative 1105,26 Newton. Now, let's make sure that we are calculating the correct quantity. Calculate the magnitude of the average force. So, if it's a magnitude, the negative cannot be there. The final answer will be F net is equal to 1105,26 Newton. That is the question. Now, they gave you 5 marks here. Guys, this question is a little bit more tricky because you don't have the time. So it's one for using Newton's second law in terms of momentum. Then it's one for calculating the time here, but substituting 1, 2, 3, 4, and a 5. Those are the 5 marks. We're almost done with this specific question. Now the next question say, how does the magnitude of the force calculated compare to the magnitude of the force exerted by the bullet on the block? Guys, this one is Newton's third law. They are equal or the same. And just for control, this is Newton third law of motion. FA on B is equal to FB on A, but in opposite direction. I hope it helped. This material, I highly recommend it. I developed this down in the description, try to get it there. And then thank you for watching. I'll see you next time. Next time we're going to solve another question of this material. Thank you. I'll see you next time. Mr. Yi here.